Good afternoon, everybody. I am Rahul Brahma from University Medicine Greifswald, Germany. I'll be giving a talk on our recent work on enhancing the retrieval of articles from PubMed using semantic search. So we created this tool and name as a VectorSage. So the number of publication published every year has been increasing rapidly. And you can see like in first plot, PubMed itself has added around 30 million articles over the 5 decades. So if we include other preprint servers like RSIB or bioRxiv like this, the number of publication will be even more, maybe 2-3-fold. So finding relevant article from all these number of publication is getting complicated. So in all this article, there are knowledge which are hidden in an unstructured data. So finding those article to get those knowledge from this data, if we don't have the right tool, we can't mine the knowledge what we want. So for mining data from this article, all of us usually use Go for PubMed. And when we search for PubMed, you can see like, let's say search for single keyword like heart attack, you will get very less article retrieved. But if you add more synonyms using the operators for PubMed search, you will get more article. So in background, these are converting keywords like splitting all the keywords and searching whatever relevant articles are heated with this keyword from the data and are showing those articles. So this traditional way of searching in PubMed database requires strict syntax which need to be followed so that we get more articles from it. So since it's a keyword dependent, so synonyms, you have to add those synonyms to get all those data. So to do an in-depth search from PubMed, it requires time. So it's a loss of time, we could say. However, the way of search that people are using has been evolving thanks to LLMs like ChatGPT, Gemini, or Meta AI. So people now want to search data in a conversational and intuitive way, like freestyle, so they don't have to follow strict query structure like we see in traditional search, like in PubMed. So earlier, in traditional search, they use operators. Now they want just to type the query in natural language. So, however, if we search in PubMed with like nature, it's not completely natural language, but some query similar to natural language, PubMed can't find any relevant article. So PubMed cannot infer beyond the keywords, and it's not aligned to the modern user expectation, what they usually are accustomed nowadays. So our goal was to develop an approach to find relevant articles, even though they don't share keywords, rather understand the biomedical concept based on semantic similarity between the articles. So as also, we want it to be queried in a natural language way. So all of this goal can be achieved by using the semantic search similarity from NLP technique. So what is semantic similarity queries? Here is an example showing like two users searching for blood pressure on adults, but they can query their input in a database in different way. However, those are their intent is same to get the data relevant to the hypertension. So for our work, we needed to convert the text into numerical value. For that, we need the embedding model. So we look like what are the embedding models available. So we found a small lightweight open source model named is Stella 400 million parameter model version fee, and we found that it is comparable to other proprietary models like in terms of performance in various benchmark. So we selected the Stella 400 million parameter model. So creating the embeddings and the training and or the indexing of the data, we first collected around 38 million articles from PubMed. All those articles were pre-processed to remove article which doesn't have any abstract. There are lots of articles in PubMed which doesn't have abstract or are in PDF format or missing texts. So all those were embedded using the Stella 400 into 1024 dimension. And using the FIES library, which is a Facebook AI similarity search, we created the vector database for these high dimensional dense vectors. We also created a keyword-based database from this data, like using BM25S from all the words from the title and the abstract. Along with that, we also created metadata so that we can get whatever information is there available for those PubMed articles. So from this, we got around 78 million data points spread about this three database, which we use to develop the VectorSage tool. So this is how the workflow works. Like whenever users put an input or query in a natural language, it is first keyword are searched in the keyword database. In parallel, those keywords queries are converted into dense embedding vectors and searched in the vector database to get relevant search result. From this, like we get two ranked search result, one from keyword-based database and one is from vector database. So again, we combine those using a custom weighted scoring function, which is a sigmoidal function, and we dynamically give more weight to the article which has a higher keyword or higher semantic value when it was searched in the database. After that, we get the metadata information and shows the result in the UI as a list of all the articles. So the balancing between the lexical matching, that is what keyword based, and the semantic is very important because user typically or usually use two way to search. Some user put natural language query. However, some of the users try to enter input or article of PubMed, so which is more working with keyword-based matching than the semantic one. So the function to combine and re-rank these two ranked lists is very important. So with this, what keyword is failed in PubMed now using VectorSage, user can query even in natural language. Since we have added the since we had added the query keyword-based search also, even if you put as keyword, it can get the relevant result. So yeah, reviewers like comparisons, so they ask us to do comparisons. We found an article like Lead Sense 2, which also use semantic to re-rank the articles. However, before using the semantic similarity to re-rank, they use lexical matching. So in essence, it is just capturing the keyword, then re-ranking based on the semantic. But our are doing like in parallel and combining them. So we get article both from semantic as well as from keyword matches. So here is the little comparison, like that lead sense to can search for sentence and paragraph, but our is like auto, you don't have to select you want to search sentence or paragraph. If you just enter any query in natural language or in keyword, it will give the relevant article. And also lead senses like cover PubMed PMC. Vector says yet not cover PMC, but might in future. Yeah, we also compare like some data from LeadSense, which has around some PLOS biology article title to see how it does in lexical matching. So we saw that like PubMed did the worst because you can't enter a long query in natural language, so it fails in most of the time. However, in VectorSage, we got higher lexical matching in comparison to PubMed as well as LeadSense, which is like in core is the lexical matching. And also we compare how it does in a semantic search way. Like we use the BioSQ test dataset, which is a human annotated large dataset for large scale biomedical semantic indexing and questioning answering tasks. So there they have a question like in a natural language, and they have the relevant article from where this can be answered. So we compare again with the PubMed and the LeadSense, and we saw that like PubMed and LeadSense not that good since it was based on keyword. PubMed, most of the time it fails, like around more than 200, like 60% times it fails. However, VectorSage did almost 2 times better those than the PubMed and the lead sense. And also we saw that around 95% of the article retrieved by the VectorSage are completely relevant to the query. However, there is room for improvement. But from this, we can say that the recall of the VectorSage is very high. And if we optimize the re-ranking and uh, merging of the two rank lists, we can achieve even better than this current score. So, however, there are also problem and limitation. We know, like VectorSage is insignificantly advanced because it finds relevant semantically similar article, but it ignores constraint. You can't make a constraint on date or date range or categories like that. But there are ways to overcome this. And also, if your quality of the data used to index the article is not good, there will be lots of like semantically likeness, but not relevant. So we implemented lots of rules, pre-processing and post-processing. Like whenever queries enter, we check are those spam and other like non-relevant queries people might enter. So we filter those. And also again in post-processing rule, we check are those relevant really or not. So the tool was developed using PyTorch and have been deployed on this URL and some of the standard tools which were used in this development. So we have added some features to do filtration of the results in current version 0.07, like based on years, mesh term, journals, and articles. And also the result can be exported or downloaded so that it can be used in other reference manager in your citation. However, the most important one is the most like button is the similar article. We have seen users like clicking most of the time this button to find similar articles. I have created a simple demo of using this one. You can enter the query as a natural language query, and yeah, this is the same query which fell in PubMed. So if we just click it, you will get the result, and you can browse it, filter it by years, authors, mesh term. Yeah, this is the journal, and you can see all the articles, authors, and you can also click inside any article to see more detail about it. Yeah. So yeah, also you can export citation in other formats, and also you can get more information about the authors, like their affiliation and the number of publication, whole history, like yeah, whole history publication. And there is one button, similar author. It's not yet deployed. It will be deployed soon. Yeah, and it can export in different citation format, and also it links to the original DOI and PubMed ID. And if you want to find similar article, you can just click the similar article to get the semantically similar article. We use the abstract of the article to find the semantically similar articles. Okay, future direction, we have been requested by the users to use semantic search to find relevant authors based on their publication. So we are implementing it so that if user enters some abstract, they can find reviewers based on those abstract, like who will be the suitable reviewer for those articles. So our main goal is to use this tool for clinical notes. So work is in progress. Hopefully it will come in future. So in conclusion, we developed VectorSage, which is an advanced biomedical search framework that addresses the limitation of PubMed in LLM era, where user can query in keywords as well as in natural language. So this is our group in Greifswald. You can visit our website to know more about us. And also the tool is live. You can visit the link to try it out, and any feedbacks are welcome. You can either use the feedback form at the website or email me. Thank you.
Already see the first question.
Thank you for the talk. I just have a quick question. Because I saw you have a filter function for mesh turn in your system. So did you use mesh turn in your embedding? Because mesh use has been leveraged in PubMed for semantic search. So I'm just curious.
No, we haven't used mesh term.
Okay.
Only title and abstract.
So when I do a search in PubMed and it lists based on most relevant for my name, it ends up ranking publications that I would not consider to be most relevant for my research. So I wonder, have you tried to see if you could apply your method to rank publications for authors and see how that compares to what PubMed provides?
Yeah, we are working on it, but we are just having a little bit of issue with author because there is no one source of truth. Like, author changes institution, they don't have any updated profile. So we are currently using ORCID, which is not completely updated, but we are working on it.
I guess I have a question about like the paper that you say the abstract is kind of missing or cannot be retrieved from PubMed. I guess I was wondering like what's the percentage of like the paper that kind of cannot be a training point in your specific data set or search tool, and or like what kind of like paper are those? I guess based on my LabMS experiments, those could probably come from like specific journals or maybe like old papers. And I was also wondering for the users, do they know like those kind of paper won't be able to find experiment tool, or is it will be able to find?
Yeah, we haven't recorded like from which paper, but while filtration, we found like around 10 million papers. Those are PDF. Some abstract, it's only they have written abstract. So it's not complete data. So I think we'll add some metric or from which year, whatever journal were excluded.
Hi,
Hi.
for the presentation. I have more of a comment than a question. In the beginning, you were showing this example of myocardial infarction and then heart attack, which is the same thing. And then when you were doing your search, you put cardiac event, which is not the same thing as this. The cardiac event is a much more broad term. So then you have one that you say, okay, PubMed returns 300,000, and then we get 3 million. But if you search cardiac event on PubMed, you also get 3 million. I guess it's because of the mesh terms. So I would recommend getting a little bit of a better example there to showcase, because I believe you when you say that it is actually working, but it's like, and I understand you want a simple example, but this is not a good one, just because cardiac event is not the same thing.
Okay, thank you.
And also one quick question from online, which is related to when you do the relevance ranking, how do you actually benchmark whether you're getting relevance right?
Oh, yeah. We use for semantic, we use the BioASQ dataset, which is humanly annotated dataset. So there we can find based on question, like from which article it should be. So it's, yeah, that's how we did it.
Let's thank the speaker again.
Oh, thank you.